Hello, and welcome to section 5.2, day 1, properties of rational exponents and radicals. All right, you're going to look at the exponents, the properties of exponents on the back of your color handout or your chapter 5 cheat sheet, all right, whatever it might be, all right, that we put into your class notebook. All right, so we're going to just review some properties of radicals to go through it first. All right, notice, for example, A here, we have the same base and we're multiplying here. So when we multiply the same base, we add the exponents. So if I turn the first, I want to get a common denominator between the exponents. So that will be 2/6 times 13 to the 1/6. So now when I multiply bases, this will be 13 to the 3/6, which will really be 13 to the 1/2 power, because my math is already pretty bad. All right. Just something to understand here, this 13 to the 1/2 power is saying the same thing as the square root of 13. Remember, the numerator is the power, the denominator is the root. This is squaring the square root of 13 to the first power, okay? If we have a choice, for the most part, if we can't simplify it, we want to leave it to the 1/2 power, all right? For the second one, notice the bases aren't the same, but when we have an exponent outside the parenthesis, we're going to distribute that. So 3 times 1/3 is 1. 3 times 1/3 is 1. Now it's 12 times 9, which is 108. All right. For example C, we have the same base and now we're dividing. Remember, when we divide divide bases, we subtract the exponents. My rule is always going to be to bring it to the higher power. If we remember here that this 8 really has a 1 as the exponent, so the higher number is 1. So I'd bring it up and subtract just to show you. 1 minus a 9th would be 8 to the 8/9. All right. Saying the same thing here, we have an exponent outside. We're going to distribute 56 to the 3/4 over 8 to the 3/4. All right, we can increase those to the same power. 56 over 8 would be 7 to the 3/4. Okay. All right, some more properties of exponents for the next 4. We don't have the same base, so we can't multiply them, so we distribute the 2. So we would have 5 to the 2/3 times 7 to the 1/2, right? Still not the same base. We can't combine them. That's as far as we can go for that one. All right, example F is very similar to example C, except now the higher power is in the denominator. So we'd bring it down. We'd still subtract. So 1 minus 1/4 is 3/4. So we'd have 1 over 3 to the 3/4. Okay, example G is very similar to example A. They're the same base. So we're going to add the exponents. Just to show you, remember when we add, we need to get a common denominator. So I'm going to turn 1/2 into 2/4. So we'd have 2 to the 5/4. All right. Example H is very similar to D, except we can take it a step further at the end. So we would distribute. So we'd have 5 to the 3/2 over 20 to the 3/2. All right. 5 over 20 is really going to be 4 to the 3/2. Now go back to it, 3/2 is really saying, this is saying the square root of 4 all to the 3rd power, all right? Do we know the square root of 4? Yes, it's 2. So this would be 1 over plus or minus 2 cubed, which would give us plus or minus 1/8. All right, so we don't always need to rewrite it unless we know the root of it there, okay? So there's some properties of exponents that we're going to go through. Make sure you use that sheet to help you and check the properties, and obviously ask any questions if you have any. All right, so now we talked about some exponents. Now we're going to talk about some radicals. All right, so it says radicals are in simplest form when they meet these 3 conditions are met. The first one is no radicans have a perfect nth power or nth powers as a fraction other than 1. All right, right? Basically what it's saying, a radicand is what's inside of the radical, okay? The radical symbol, what's inside, it's a radicand. So we basically can't have a fraction that we can't rationalize the denominator with. The second one is no radicands contain fractions. All right, and the last one is no radicands appear in the denominator. All right, and this is going to go back to stuff you guys did in the past about rationalizing the denominator and things like that, okay? All right, so if you turn the page or scroll down, however you guys are doing it, we have a couple different properties of radicals, okay? The first one is the power property, and I'm just going to show you that if we have the nth root of a number a times b, all right, whatever it can be here, it's the same thing. We can separate it to the nth root of a times the nth root of b, okay? And this radicand's not over that. It's saying that they're just going to be multiplied by each other. Easiest way I can describe that to you guys is when you used to have to simplify radicals, like the square root of 12, right? We could say the square root of 12 is really the square root of 4 times the square root of 3, and that would help us because it's really 2 square root 3, okay? Just to kind of show you what we're talking about there, all right? The other way we can kind of think about it.
Anna Marie Galante, if you're in the building, can you please call Ann at extension 6201? Thank you.
Sorry for that. All right, is if we had the cube root of 4 times the cube root of 2, that's really going to give us the cube root of 8, and we know the cube root of 8 is 2. Okay, so just showing you either way. We can either break it down from 12 and get 2 root 3, or if we had 4 times 2, we can multiply them to get 8, and we know the cube root of 8 is 2. All right, the quotient property, obviously, just deals with fractions and division. All right, so when we go through here, the the nth root of a over b can really be written or as the nth root of a over the nth root of b. All right, and if we're given something like this, we can write it as the inverse. That's why I put the equal sign both ways. Our example, if we had the 4th root of 162 over the 4th root of 2, we can really rewrite that as the 4th root, one big fraction, and the 4th root of 162 over 2 is 81, and we know the 4th root of 81 is 3, but because we took an even root here, we need plus or minus 3. Okay, so these are just some other properties that you're going to need to refer to when we're doing some of these and know how to use them. All right, in this example, or this lesson, there's going to be a lot of ones that are going to be simplified, nice and neat. Tomorrow's lesson, they'll be a little bit more complicated, but we'll start with the basics today. All right, the cube root of 12 times the cube root of 18, we don't know either of those cube roots. But if we do the cube root of 12 times 18, that gives us 216. If we look at our sheet, the cube root of 216 is 6. All right, so that's how we'd simplify this expression. All right, we don't know the 5th root of 192. We don't know the 5th root of 6, but we can really rewrite it as 192 over 6. 192 over 6 is 32, and the 5th root of 32 is 2. Notice we're taking odd roots. That's why we're not doing plus or minus. Okay? All right, same thing with C. We don't know the 4th root of 80. We don't know the 4th root of 5. But if we do 80 divided by 5, it's going to be 16. Do we know the 4th root of 16? Yes. It's 2. But because we're doing an even root, we need the plus or minus there. All right. Now we're going to kind of go back to the product property rule of radicals, kind of like example A here. We don't know either of these cube roots, but if we were to do 4 times 128, that would give us 512, and the cube root of 512 is 8. All right, so we're just kind of manipulating the powers that we know of radicals and exponents to simplify some of these values. All right, our last page. Last page is going to start off by something that we call conjugates. all right? For any denominator that is a sum or difference involving square roots, we're gonna multiply both the numerator and the denominator by the conjugate of the denominator. All right, remember, conjugates differ only in the sign in between them, and it makes it nice for us because when we multiply them, the middle terms cancel out, and that's what's gonna help us get rid of the radicals. So, for the first one, we know the conjugate of the denominator would be the square root of 7 plus 2. So we're going to take the original problem and multiply it by the square root of 7 plus 2 over the square root of 7 plus 2. All right, the reason why we do that, all right, is our denominator is going to be our first term squared minus our second term squared. That's what happens when we multiply conjugates. And then we just distribute the numerator. 1 times the square root of 7 is the square root of 7. 1 times 2 is 2. Okay, we need to go through and square our denominators here. So this would be 7 minus 4. And then we're going to simplify. And that's our final answer, the square root of 7 plus 2 over 3. Now notice it's in simplest form because we don't have any radicals in the denominator. All right, we started with 1 in the denominator, so that's why we need to do this. Okay. Example B, we're going to start off and talk about the conjugate again. The conjugate of 5 plus the square root of 6 is 5 minus the square root of 6. So we're going to take 3 times 5 plus the square root of 6 and multiply it by the conjugate. All right, I'm going to start off with the denominator again. It will be our first term squared minus our second term squared. That's the nice part about multiplying by conjugates. All right, 3 times 5 is 15. 3 times the square root of 6 is 3 times the square root of 6. Okay, think of the radicals like variables. We can't combine them. It doesn't become the square root of 18, right? If we did 3 times x, it would just be 3x. So that's the easiest way I can kind of help you out there. So this will now be 15 minus 3 square root of 6 over 25 minus 6. 25 minus 6 is 19. So that's our answer. Now, if this number was 18, I know it's not, we could then simplify it further because every term would have a 3 in common. So remember, if we want to simplify here, every single term would need to have something in common. In this case, that doesn't work, so we're good there. All right, last couple examples, just wanted to simplify these things. All right, I'm going to show you the first one to kind of think about, for some of them, the properties of exponents as well to kind of help you understand. But for tonight's homework, all of them will kind of simplify nice and neat. So if we have the cube root of 27 times d to the third, we can rewrite that as the cube root of 27 times the cube root of d to the third. We're just using the properties of radicals that we know here. How does that help us? Well, what's the cube root of 27? Well, that's 3. And what's the cube root of d to the third? Just d. So that's our answer. Okay. Now, if we want to use the quotient property with the next one, we can really rewrite it to make it easier for us to see as the 4th root of x to the 4th over the 4th root of y to the 20th. All right, I think we see easily that that will give us x because the 4th root will cancel out the 4. Now I'm going to show you this extra step this time, but if we think about it, we can really rewrite the 4th root of y to the 20th. The numerator's the power, the denominator's the root. All right, and I'm actually showing you the top one as well. All right, understand why it cancels out. The 4 over 4 is just 1. All right, and then we have 20 over 4, which is y to the 5th. Okay, now I know I took a 4th root power here, so I want to make sure I put the plus or minus in front of it. All right, just to kind of stay consistent. If it does say, assume that all variables are positive, something like that in your notes or in your homework, whatever, you wouldn't need the plus or minus, but just to stay consistent, I like to still put the plus or minus there just to make sure we're all on the same page. Okay? All right, if we look at example C, it's similar to A. I would say the 4th root of 16 times the 4th root of x to the 4th times the 4th root of y to the 8th. What's the 4th root of 16? That's 2, plus or minus 2 technically. The 4th root of x to the 4th cancels out to just be x. All right, and to show you the next one would be y squared, and just think, if I rewrote, I'll do it down here at the bottom, y to the 8 over 4, that's really going to give me y squared. All right, just using our same rule for the numerators of power, denominators the root. Okay, last one is very similar to B, except we got a couple more pieces to it. We have the cube root of 8 times the cube root of y to the 9th over the cube root of 27 times the cube root of x to the 12th. All right, well, what's the cube root of 8? 2. The cube root of 9, or y to the 9th, 9 over 3 is 3, so it'd be y cubed. Cube root of 27, 3. Cube root of x to the 12th would be x to the 4th. All right, so if you have any questions, please let us know. Your homework will be posted soon enough. If you have any, as you go through your homework and do your notes and things like that, make sure you have that sheet out with all the properties. I think it'll definitely help. Have a great day. We'll see you guys later.